I'm back. Can't get rid of me. It's your worst nightmare. Anyway, these are all of the identities that you hopefully will remember. We don't use them a ton in first semester. We use them more second semester. They're just kind of here to sort of jog your memory and help you remember. Something that you do want to notice down here, though, at the bottom, is that some of these are even and some of these are odd functions. And so remember, in order to tell if it's even, if I plug in negative x, I should still get the same value for y. And so I notice on here, I forgot to write even. And so I notice, oh, look at cosine. If I plug in negative theta, I still get positive theta. And then remember, for odd, the rule for odd is if I plug in negative x, so f of negative x, I get a negative y value. Those are in fact negative signs. And so then when I look over here at sine and tangent, oh my gosh, I plug in negative x and I get a negative y value. Same thing, plug in negative x and I get a negative y value. So these are odd. That will be very useful. Of course, I'm going to clear this. Of course, your Pythagorean identity, sine squared plus cosine squared equals Mrs. Torres, because she's number 1. That will help you not forget. And of course, these are the alternate versions when I move one of the trig functions to the other side. And I think I showed one class, so I'm going to do a quick rendition again. If I'm best friends with sine squared and then all of a sudden sine squared talks bad about my mama, then it's on. And so I come to school and I don't want to see sine squared's face, so I can't kill sine squared because I don't want to go to jail. I'm too young. And so I'm going to divide everything by sine squared all the way across. And of course this turns into 1. There it is. And this turns into cotangent. There it is. Equals, and this turns into cosecant, so there it is. And then of course the same is true if cosine talks bad about my mama. I'll have fit and I'll have to divide everything by cosine, and that's what generates the other trig identity. So I don't really need to memorize these other two. I can generate them every single time. Those will probably be the most useful. Okay, so we're going to do some examples down here below with the trig identities and verifying. One thing to notice is what's going on both sides. So when I look at the first one, I notice that this is a single fraction on the left, but there's 2 pieces over here. So I have to create 2 pieces. So one thing that I might be able to do, and I give it a shot because you never know what's going to work, is I'm going to separate the top because it's like undoing addition of fractions. And you'll see here in a second, and you could check mentally. So they have a common denominator, which would allow me to subtract them together, and I would get what I started with. And so of course now you go, oh, I see where she's going with this. So one of the cosines cancels here, and one of the sines cancels here. And so then I have just cosine over sine, which is cotangent. And over here, I just have sine over cosine, which is tangent. And oh my gosh, look at that. It equals what was on the other side. Oh, I wrote on my face. Ow, that hurt. It's like a tattoo. Ooh, a math tattoo. Ooh, isn't that cute? T. Okay, next one. So if you're paying attention to the fact that, oh my gosh, there's powers of 4 and there's powers of 2, which leads me to believe that this, since it has 1, 2, 3 pieces, might factor. So I'm going to give it a shot. And I'll have to do it in the next video, so I'm going to pause and go to the next video.